We're solving problem 21 from the 2019 AMC12A. This is solution 1. Let z equal 1 plus I over square root 2. We want to find what this sum is. So first, what you can do is you calculate z to the power of 4. If you just calculate z to the power of 4, or z squared, you calculate z squared. But we can do z to the power of 4 for this case because you don't want any square roots. This is simply -1. We see that all the even terms, so i.e. z squared squared and z to the power of 4 squared. So like all the evens, z squared squared, z 4 squared, z 6 squared. All these terms, when you add them up, they cancel out. Even if you add the reciprocals up, they still cancel out. So we can rewrite the expression without the even terms. So we have z 1 squared plus z to the power of 3 squared, dot, 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 plus our last term, z to the power of 11 squared, times, you do the same thing for the reciprocals, z to the power of 1 squared plus 1 over z to the power of 3 squared. And our last term, similarly, 1 over z to the power of 11 squared. So this is the point where we see that z to the power of 1, say, is equal to z to the power of 9. So that means these values cycle after every 8 powers. Then z to the power of 1 is z to the power of 9, z to the power of 25, all the way up to z to the power of 121. So since these are equal, we can just rewrite it. This one, there's 6 of these. In this, you can just literally just count them out. There's not a lot. So this is 6 times z to the power of 1 squared. Similarly, there's you can do the same thing here. Since these z's are all equal, this is going to be, when you sum it all up, 6 over z to the power of 1 squared. So we multiply these two together. So these two basically just cancel out. So our product is 6 times 6 is 36. And that is our answer for this problem.